Hello, this good evening, and I'm doing a recording on a project that I did back at school before I graduated. I am back on a research project. So the research project I did is about machine learning. It's about machine learning. As part of demonstrating our IT skills, I want to also show my project, my research work that I did. So we should go ahead and okay. So my research work is about cabbage disease detection. So as part of my requirement to graduate in my former school, I was supposed to come up with a project and make a research about it and also develop the project before I'll be able to complete. So this is the project, and this is a documentation I did. So after looking at the documentation, then we will go and look at the real project. Yeah, yeah, mm, it's a lot. Yeah, okay, so this is the beginning, yes, and the project is developing a selected cabbage crop disease detection model using a convolutional neural network. And in my case, we use a model called Inception V3. So Inception V3 is a convolutional neural network model. So this is the research work, and this is the documentation of the research work. So we go through, and so this is a literature review. So literature review, and I did literature review about the work, and also um, this is methodology. I came up with a algorithm. Yes, so quickly I also show the projects. This is the folder containing the model and everything, the coding and everything. So this is the training model, and this is the application that run the training model. And when you go into data set, as requirement, I need to gather data set. So some of the data set, they are taken from raw farm, and other data set too, I got them out of online data sets such as Kaggle. So Kaggle also help to gather data set for machine learning research work. So this is a raw image that I went to a farm to take so that it will help me in my detection. So this is image taken from a farm, different kind of image of an infected cabbage. So this cabbage, they are all being infected. Some is not infected, some is infected. Yeah, so I'll go to I'll go straight forward to launch Anaconda. So I use Anaconda to run the program because it's a Python program. So I need to run an IDE for the program. So I think Python takes slow, but it will surely come because okay. So I have Anaconda here. Anaconda is running, but I use Spider. So I use Spider, which is a scientific Python development environment. And mm, yeah, okay. Okay, so it has loaded. Good. So this is the project, and I can walk you through the code and how everything works. So this is the training. in the training, I have to train the images so that the algorithm will be able to understand what I want to do. So I have to train the model I'm creating, the model I want to use to detect the diseases also. So the whole idea is that we we came to discover that some of the farmers struggle to supervise their farm, and also some of them also hardly understand the kind of infection that is affecting the plants. So I decided that okay, I'll come up with a solution. So this is a machine learning application that will only take images of the crop and also predict what is happening to the crop. There have been a lot of machine learning research about crop farming and all that, and I also contributed to that. So in the code, we first have to import TensorFlow, and TensorFlow is from Google, and also Inception V3. So this is the main model that really do the detection. This is the model developed by Google, and this model help in identifying and classifying images. So this model is really good in image classification. So it can detect objects on images. Yes, so that is why I use Inception V3, so that Inception V3 will be able to analyze everything on the image and also distinguish between images that are not good and the ones that are good. So Inception V3 really was the best option, though as at the time I was doing my project. But there have been a lot of improvement and different models out there. So yes, good. So this is important. So we have to first of all import all the libraries that we are going to use. So after importing your libraries, we have to set the path. So I'm setting the path, training path. So the training path means that once I'm training the Inception V3 on the images I want is to detect, I have to set the path where the images are located. And the images are located on the folder. So this is the folder. When you go into the actual project work, you come to dataset, you can see I have training images here. So it will go into dataset here, go into dataset, and then look for training folder. So whatever image found in the training folder, the Inception V3 have to learn it. It has to learn the images so that it will be trained to understand what image it's going to work on. So the image we are giving to the Inception V3, it will use those images to make the classification. So if I give maybe animal images to the Inception V3, then Inception V3 will learn all the animal, the kind of animal I've given to it. If it's about dog, it will study about dog, all the images. So that is the data set I'm talking about. So I gave cabbage images to Inception V3 to learn the images and also distinguish the differences between two diseases. Yeah, so that is how come I set the path and all that. So I'm calling Inception to use Inception V3 input shape and image sizes. And as at the time I was doing my images, I was cropping the images to 150 by 150 so that Inception V3 will have the images all in the same and equal sizes. So when I come here and I come to training, you find out that I have images here that the Inception V3 has to learn. So it is learning 4 groups of images. You can see 4 groups of images here. I have disease one. This is the type of disease affecting cabbage, and this one too. And then I have healthy cabbages. So I have to be able to study all these images and know the differences, so that whenever you give it any image, it will be able to predict which one you have given to it. In that case, um, so this is the code, and this is the model. So model input incepting dot input output to be prediction. So the output that the model should give to be a prediction. So after the model is being able to predict, after the model is being able to learn the model, learn the images, I want us to also plot a graph, because the graph will help me to know the number of times it is able to learn the images. So in that case, we have to run an epoch. So now epoch is the number of times the inception, the model, the number of times the model should learn the images. So if I give it one epoch, it means that the Inception V3, the model to learn only one times of the images, one time. But if I give it 20, it means that it will learn the images over and over and over, like 20 times. So when it does that, it is able to predict accurately. So for the accuracy, for the purpose of accuracy, you have to let the model learn the images over and over and over and over, so that it will be able to capture every single detail on the image, every detail on the image. So so here, this is how I am running it. Now the R is equal to model.fit, and the training set validation data to be validating set. So now the epoch is going to be running, I'm going to run is 20. The number of times I want the model to learn the images I have given to it, which is the data set. Yeah, so I have my images are here. I have training data set to be 150 by 150, and then the validation data set to be 150 by 150. Okay, so from here, this is the plotting. So this one will plot. Here is where I make I have to plot the model so that you understand how it went. So in this case, I will run the model. And when I run the model, it will start learning. Now it has not learned the images now. So this is the console. Here is where it will run, and this is the training.py. So the Python program is going to run. I'll go to run, and it will have to run from here. Okay, so now it has found 235 images belonging to 4 classes, and then it has also found 240 images belonging to 4 classes. Yeah, the difference is about the training and the validation images. So now epoch 1 of 20. In this case, it has to run over the images like 20 times. So whilst this one is going, it means that the model is learning the images. It's trying to study the image I've given to it. Yeah. So it will run over and over and over 20 times. And because of the computer system requirement, it's kind of making it slow, but it will run over and over and over. It will run over and over and over up to 20, and then from there it will bring out the results. So for analysis, you can see that the validation loss is higher because it's 1.3714, and then the accuracy is 0.6833. So this means that in the beginning the algorithm has gotten losses because it doesn't really understand the images, so it won't be able to give an accuracy which is higher. So in this case, my losses is higher because the losses is higher. Total losses, validation losses is very higher. 1.3714 is very high. So in this case, it has to learn again. So it will learn the second time again. So you can see the difference between this. It is trying to understand the images now. So the losses has reduced to this, and then the validation is going up. So before it will reach the 20, the model will be able to understand the image very well, and then the losses will be very low, and then the accuracy will be very high because we are thinking of accuracy. And another thing was also to determine the higher percentages. So at what level can this predict a correct image of cabbage, and then it will bring a result. So it has to, let me take my image, come here. Okay, so now the higher accuracy, because there have been a lot of research about this, and people have been predicting diseases in crop, in different type of crops and all that. And this is the accuracy now I'm getting. So now validation, as the epoch ran on the 7th, it ran on the 7th time. Now the accuracy, the loss is going to 0.151143, and then the accuracy is now going to 90, so 95, 0.9583. So now we say this is around 15%, and this is 95%. So at this point, it is understanding the images very well. Also, we wait to see how the accuracy will rise, because it is good to get higher accuracy. When you get higher accuracy, it means that your model is really good. The model can detect anything you give to it. So if it is not the object you want, I mean, if it is not the data you have given to it to learn, it will reject it. So I want to predict between cabbage, the good ones and the bad ones. Yeah, so if I want to predict between the good ones and the bad ones, I have to train a model to understand, and then the model will do that. So that is what I'm running now. That is what I'm doing now. No, so now I'm running the model over the data set, so that it will learn from the data set, and then whenever I use the model, it should be able to detect disease, if the cabbage crop is having a disease or not. So it's still going. Now it's 13. Maybe I'll pause the video, and when it gets to 20, I will. Okay, so now this is 14. I think we are level 6 round, so I will leave it. I will not pause it. Okay, so 15, 16. Okay, so the losses keep decreasing, because it is able to now identify the kind of images it has to learn. So that is the power of Inception V3. Inception V3 really, it can read images and also identify images according to the data set that you give it to it. So it will be able to do that only based on only the images I have given to it now. And according to my data set, I have two type of diseases that I am basing on. So the training data set, I have these two diseases, black rot. So this is the black rot images, and they all have the same image size. The width and the height are all the same, and the data set is small, it's few. Maybe as time goes on, I can increase the data set and also expand the project, because I want to make it a real-time detection project, so that in real time, when you deploy it on a mobile phone, it should be working real time. So when you open it, when you open the app and you point it to the cabbage, it should be able to give you the kind of disease that is affecting the cabbage. Yes, so that is something I'll work on as time goes on. So I think the epoxy is done running. So now it has gotten to 20 over 20 now. Okay, so now we have loss of 0.0627, but in the beginning the loss was higher, because in the beginning the loss was 1.3714, and then the accuracy was 0.6833. So this means that in the beginning the algorithm or the model Inception V3 didn't understand the images, the data set, but as time goes on, as it's run over and over and over, it has come to understand the images, and now it is running a loss of 0.062%. So in this case, we say this is below percentages. Yes, and now it has a validation accuracy of 0.98.75. So I can say this is 99%. So now it has been able to understand the images 99%. It means that any image that you give to it, if it is not the data set we have given to it, it will reject the image. Now it can be able to distinguish between the two different diseases that I have given to it. Okay, so for me to use this system, now this is the algorithm and everything is working fine, but there has to be an interface for this. So the interface is where I came up with this app. So this app is where my interface will be basing on, and the interface, for you to run interfaces, you need to add HTML and CSS, and also Flask. This is Flask. So this help to run HTML and CSS in Python program. So I imported it. So I imported Flask. I redirect URL for and request and render template. So the render template is where my HTML and CSS will be. So when you go into the folder of my dataset, the application, you come to see that I have a template here. So in the template, you'll find the HTML and CSS, all the code that I wrote about the images. So when the model detects that the image I've given to it is a disease, then it has to read this HTML, this two HTML. If it is healthy, it will read this HTML. So this is helping you to let the model predict. So the model will predict, but when the model predicts, there has to be an interface. So this is not the interface for the model to understand and predict. Okay, so I'm going to run the app. So this is where the model will be saved, because I saved the model after running it. So here you can see when the training was done, it has to be saved to disk. So when it's saved, this is where it is going to be saved to the directory. So model / cabbage model underscore inception and .h5. That is it. So when you come to the training, you have to find it that it has to be saved. Yeah, so when it's done running, just like you can see here, when it's done learning the model, it should be saved. So I'm saving it to Dex. So I'm going to save model cabbage underscore model underscore inception underscore h5, and then I'll print save to Dex. That is what you see here, save to Dex. And when we come to app, I have to call the model, because that is what I'm going to use to do the predicting. So for it to detect anything, I have to call it. So now cabbage underscore model underscore inception dot h5, I call the model here, and then everything continues from there. So this is an if condition. So this if condition is telling us that whenever there is a predicting that comes from the model, I am choosing between this thing. So this is the interface. So these are interfaces I've given to each model, each detection. Yeah. So I'm going to run this, and I expect it to run. And when it's done running, it is actually going to use a server. This is error. Okay, so there is a trace back most recent call last, and 7 flags up. This is okay. So I'm running on this port 1990, and I'm hosting it on this IP address. Oh, I think the IP address is the reason why, because I think I have connection issue with my network. It actually doesn't use internet, but because of the network I am on, if I want others to have access to it, I have to put it on a network. That's why it's running on this one. But I can see MD. Okay, so I type CMD here because I want to check my IP address. Okay, so my wireless LAN is 192.168.43.151. Okay, so I have to give the same IP to the model, the app to run, for it to run. So this is, I'll only change 20 to 43, or maybe yeah, I think 43 will be good, or 40 to 43, and this is 151, and this is 151. Okay, so I expect that the program should be running, because the error should be solved, and it should be running here. Okay, good. So now it is running on this address. So in this case, if I am hosting it online, then this will be a different address, but because I am hosting it local on my machine, that is why I put this IP addresses there. I just canceled the program. Let me run it again. So this is the console. So on the console, when you type Control-C, it's going to cancel the command and then start a new command. So I have to rather do like this and click on copy. Then I'll open my browser, go to new, and I will paste this in here. Okay, paste and go to so this is the IP. Good. Yes, so now this is the interface. We have the interface here. This is the interface, and I'll improve it as time goes on, but for testing sake, because this is going to help us to be able to. So now I want to test this system, so I can select any image. Maybe select this, and then go to detect, and it should be able to detect because it's running. So in the code, you can see that there have been a request here. So full dispatch request, because I have requested that I want it to detect something for me. And so type error, the view function did not return a valid response. The function either returned none or ended without a return statement. Okay, so whatever happened on the interface, I see it. So you can see that it returns something that is unidentified object. So this is unidentified object. This is an unknown object to detect. Okay, so I got the same thing on the console. Now it has returned none or ended without a return statement. Okay, anyway, so now I want to also go back and choose a different image, assuming I will look for my images on the farm. These are images from farm, so image from farm, and I will select this one. Okay, so good. Now you can see this is a black rod disease. So there is black rod disease on the cabbage leaf. Now look for a better agrochemical to treat this black rod disease as soon as possible. Yeah, so this is one of the predicting. It has been able to identify between an image which is a cabbage and an image which is not a cabbage. So it know that this is the cabbage, but now this is an infected one. So let's go back and also try to do a different thing. Now let's look for another image and also upload the detect. So now it's going to run in detect. There's another black rod disease. There is a black rod disease on this cabbage leaf. Okay, and I will choose another image, probably maybe this image. So this image look different than the other one, so let's see what the algorithm will bring to us. Okay, good. So this is an healthy cabbage crop. So now you can see the cabbage is healthy and there is no disease on the cabbage. And that is true because the cabbage is healthy because based on the image classification. So this is what the model really do, and whatever happens, I got a report here. So whatever disease, whatever you give to the system, I got a report here. And this is a server running on my own machine, and it's not. So you can see this is a development server. Do not use it in a production development. Yeah, so the server I'm using is this one, WSGI server instead. So it's run on the system. So I will thank you for your time and attention, because I only wanted to demonstrate the documentation and also how the system really work. And in the future, I plan on to develop the system so that it can be used in the real world by farmers, and also it will help people who literally understand the cabbage crop diseases, the type of diseases, and also maybe expand the project to a level where maybe it can be deployed on a drone. So when you have a drone, the drone will be flying over the farm. When the drone fly over the farm, then it will bring you results of your farm. So in the analysis, you find that these are the cabbage that are spoiled and these are the cabbages that are not spoiled, and the healthy and then the unhealthy one. So in the near future, I plan to expand this project and make it a real project and also a real-time project. So in the real time, I expect that you should be able to use a camera. So when you open a camera, you should be able to open and bring you a video. my camera is not working because I am actually using the camera to do recording, so it won't be able to give access to the camera again. So in this case, you should be able to take a real-time picture of the image and then you save it. So as soon as you save it, it should be able to come and then predict for you to get the results of what you want. Yeah. Thank you, Katos.